Hey everybody, Mr. Regan here, and we're looking at the last video that deals with those short answer questions where we not only have to kind of explain what's going on with the motion of the objects involved, but we also have to kind of explain different cause and effect relationships within those collisions, and we're graded on that rubric. So before we even start looking at these questions, I want to point out something important in the rubric. One, student correctly infers how the forces within a collision cause a specific effect. With this first one, we're trying to infer about how a specific force within a collision caused a specific effect on the objects. In this case, we're trying to infer about how the collision with the satellite with crashes 1 and 2 caused a greater change in motion for the satellite. Okay, so we're looking at that relationship there. And in the second one, again, correctly infers how the forces within a collision cause a specific effect. We're looking at how this collision here causes a specific effect in regards to us figuring out the mass of the object. Both of these questions, okay, had a second part to them where it kind of said, explain your answer, why you think this is it. And that's where you had to kind of, again, infer about how the forces within the collision cause a specific effect. And you had to explain the relationship between force, mass, and velocity before, during, and after the collision. You pull a lot in there, okay? So what was going on before, during, and after the collision that helped you infer about the cause and effect relationship? Prior to these questions, you looked at a lot of multiple choice things where we looked at how larger massed objects need larger forces in order to change their velocity. We also looked at how objects that collide are going to exert equal forces in opposite directions. We looked at how a force is going to be required to change the velocity of an object in any and all situation. And last but not least, we looked at how all three of these things play together to create this relationship between between force, mass, and velocity. So let's go ahead and dive into our simulator to figure out which crash caused a greater change in motion for our satellite. Was it crash 1, 2, or did they have the same change? Now, a few things before we get into it. Number one, the satellite will have the same mass in both crashes. Crash 1 has a larger asteroid. Crash 2 is a smaller asteroid. Both asteroids change their velocity equally. So this is a lot like the skateboarding question we looked at in earlier parts when we had our different massed objects. So let's go ahead and look at what's going on and then how we have a good solid writing section here. So in our simulator, we have object A and B. Those are our asteroids, okay? Object A is our first crash with our heavy object. And then crash 2 is our lighter object colliding with our satellite. We know that during the crashes, the satellite had the same mass. We know that after the crash, both of them after they collided, both of them had equal changes in their velocity. And you can see that here. When object A, the heavy object, collides, it changes by 2, slowed by 2. B, same thing. Started with 10, went to 8, slowed by 2. Trying to figure out which crash, was it this one or this one, caused a greater change for the satellite, which is going to be these objects here. We're looking at which one has a greater change to its velocity. Well, let's pull in some of that important information we know. Number one, we know that in this collision, whatever forces are applied to one object is going to be applied to the other. Doesn't matter whether it's large or small, collisions cause the same opposite but equal forces applied. Okay. We know that it's going to take a stronger force to move a larger object, and it's going to take a smaller force to change the velocity of a smaller object. Now, the most important thing here is this after effect. Okay. So since our asteroid A has a larger mass than B, it's going to require a larger force to slow it down in the same regards to the lighter asteroid here. Okay. So since A changed speeds the same amount as B, we know that this one's going to require a stronger or a larger force within the collision, okay, in order to have the same velocity change. So why does that matter? Well, remember, object A collides with C. So because this needs a larger force to change it the same amount, C is going to experience that larger force. Because C and D are the same mass, okay, because C and D are the same mass, they're going to experience that larger force for C than D would, okay? So if we run the simulator, we would look to see whether or not that's the case. So we run the collision here. You'll notice two things. Our larger object, like we said, needed that larger force, okay, in order to change our satellite, okay? I'm sorry, in order to slow to that 2 kilometers. Our lighter object needed a smaller force to slow by 2 kilometers. Again, notice 10 to 8, 10 to 8, that's a change of 2. Larger object needed a larger force to change its velocity to 2. Smaller object needed a smaller force to change it to 2. Whatever A felt, so did C. Whatever B felt in terms of the force exerted, so did D. Notice larger forces, smaller forces. So which one experienced the largest or the greatest change in motion? Well, if we move this here and look at the data, well, object C, that's the one with our heavier crash, okay? This one, again, 7 to 12, changed by 32, changed its velocity by 32. This bottom one, B to D, D changed from 1 to 17, 6. So the correct answer is crash 1 caused a greater change in speed for our satellite, okay? In the collision, where they both experience the same forces, okay, whether it's our first collision or second collision, doesn't matter, they're going to feel those forces in opposite directions, but they're going to be applied to both objects. It takes a stronger force to move our larger object by 2 kilometers per second than it would a smaller object being moved by 2 kilometers per second. So, since this asteroid, okay, has more mass, has an equal change in speed, it's going to need a stronger force when it collides. Because it collides and has a stronger force, C feels that stronger force. That stronger force with the collision causes it to change more. Okay? So, if you're somebody who's looking for more of a connection to the rubric, let's take a look. In that inference, we inferred how the forces when the collision cause a specific effect. Okay, we talked about how the larger mass needs a larger force, okay, causing that satellite to change its speed more. We explained the relation between force, mass, and velocity before. So we talked about how the objects had different masses before. During, we talked about how the larger and smaller masses needed larger and smaller forces. And then after, we talked about how those larger and smaller forces applied would cause larger or smaller changes to the velocity of the satellite. Okay? Pulling everything in there and answering that section in a complete response. So, in this section, the correct answer would be, whoops, not that one. My apologies. The satellite would be A. If you're looking for the answer to B, you're obviously going to pick A, B, or C there. I recommend practicing writing out kind of what your answer might be. Again, kind of pulling in that before, during, and after. And if you're looking for kind of the best response that you could have for that one, here you go. If you need to pause the video at this point so you can kind of read through and kind of examine your options, go for it. If you have questions as to why this is the best answer or how this answer clicks with the rubric, definitely check in with me. Otherwise, that's how you would complete the short answer questions. If you have questions, reach out. Otherwise, great job. You have one last section that's just a quick check-in, and then you're done. Make sure you email your teacher, me, so that I know you're done and can send you the new summative. Great job, and Good luck in the next summative.